Welcome everybody. Today, as you already noticed, we make all our presentations in English. So I will stay with English. And this is like every day afternoon, we go a little bit more into depth. And so this is now a presentation a little bit more for the experienced one. So I will try to avoid to start with the very basics. One question, who of you attended the presentation in the morning? 1, 2, okay. So we'll see, maybe we will have to repeat a little bit of the basics because I don't want anybody of you to get lost during this presentation. And because it's a little bit goes into detail with LED and especially color rendering and color quality. So this is sometimes some complicated stuff, we will see. But I will try to help you through all of this. For those who haven't been here in the morning, my name is Dennis Jackstien. I am now working for ARRI for around 9 years. Many years in R&D, especially for the LED products. I was part of the team for the little low caster, and also, like when we made the first steps with the L series, I was still in R&D, and then I switched to the product management, and traveled the world and met customers everywhere. And now I work as a freelance tutor. What I do here? Doing lessons for light technology and lighting design. And so let's have a look at the topics for this afternoon. LED technology is for sure the main part. And because it is so important for LED, or other way around, if you want to work with LED, you have to know about judging color quality. At least if you care a little bit for picture quality. LEDs, they have some problems with color and color quality, but there are also possibilities to get a very good result with LEDs. I will also tell a little bit about high-speed shooting. If you were attending the Astron presentation, right, it was just before mine, there were also already some informations about high speed, so I will, give some additional informations. And afterwards, after we have are flooded with all this theory and difficult technical stuff, we have the chance to use all the fixtures that we have here, of course, especially the LED units. We have more LED units over there, and we have a couple. And we have the chance to use them by ourselves and to do some smaller lighting design workshop with LEDs. Okay. First, just to introduce you a little bit to the advantages and disadvantages of the LED. A very short look on the other main technologies that we have in film and television lighting: tungsten, daylight discharge, and fluorescent. And all of these three are still used for sure. LED is now, we could say, taking over. It's not the right choice for all applications, but it's getting more and more important. But these technologies are still used for sure. So let's have a closer look. Tungsten, that's a very, very traditional, very well-known technology. What do we know from tungsten? Tungsten is maybe not the most efficient technology. Tungsten produces mainly heat and only a little bit of light, but mainly because it's a very low-price technology, it's still important, still used. I think there are not many film shootings out there who work completely without tungsten. But of course, LED is, especially if we talk about studio solutions, TV studios, LED is taking more and more of this market away from tungsten. If you look down here, as a value given, TLCI and the 99. I don't want to tell you too much about this now. Just this is a method for judging color quality. And as far as what I know, this is a much better method than CRI. You might know about the CRI, color rendering index. This is the popular one. This is the one that is used everywhere. I would like to introduce you to TLCI because this is a much better method, especially if you work with LEDs. But I will explain this in detail a few slides later. Just to know what is written here, TLCI 99. This is same as with CRI. 99 is a really, really good value. So 100 is the maximum. 99, it's perfect. You know efficiency, the lumen per watt. You know about that value? Yeah, I mean it's how efficient, how much light do I get per watt? Yeah, and as we know, tungsten is not the most efficient one. Second technology that we use a lot, especially in movie lighting, HMI, this is much, much more efficient. Just here, 90 lumen per watt. Sometimes it's even 95. So a very, very efficient technology, HMI. We have HMI fixtures over here. These three are HMI, and absolutely important technology for all movie productions. So there's no way to get around HMI. HMI is very powerful, but also very expensive. But if you have to deal with daylight, if you want to, if you're working outside or you want to light really big sceneries, there's no real way to do it without HMI. So that's why it's still important. And besides that it's expensive, there are some more downsides. As you might know, always you need a ballast. All our fixtures, if you look closer, they all have a ballast. No HMI without a ballast. And they have their run-up time, which can be a problem for some applications. But it's just by far the most powerful light source that we have in the market. So we need HMIs, and it will take many, many years, if ever, LEDs are able to replace units like this, especially if we talk about bigger HMIs. I think maybe it will never happen. Yeah. Fluorescent, still used also in studios and also on location. It's not a core technology for ARRI. We have fluorescent units, but we are really concentrating on HMI and LED. Fluorescent, also efficient light source, very good lifetime. And yes, I mean, fluorescents, they are not so powerful. Usually you need more than one tube to form a light source. And this is maybe one of the main disadvantages of fluorescent, because they are so big. Yeah, it's only possible to realize soft lights with fluorescence. I mean, there's no chance to get a fluorescent inside a Fresnel unit. So limited applications for fluorescence. And even if we talk about fluorescent soft lights, you will see, at least if you walk around at Cinec, LED is also here taking over. Yeah, LED is taking the market from fluorescent, and so I don't want to tell too much about fluorescent at this point. Let's jump to LED. LED is, it's known, it's the future technology. It's, getting into more and more applications, and it has many, many benefits, but as with all new technology, there's also always some kind of hype. LEDs are a hyped technology, and I like to call it the LED buzzwords we have here on this slide. And all of these, LEDs produce no heat. LEDs last like forever, and they will replace everything else. This is all not really absolutely true. It is not completely wrong, but there's more to know about it than just these simple buzzwords. And also this point, strange colors. So people are a little bit still afraid of LEDs because they think they produce strange colors. And this is also true. LEDs have color problems, but once again, it's not as easy as this. Yeah? It's a more complex topic, and it's also possible to get pretty good colors with LEDs. We will see it on the next slides. Let's have a closer look. I did it also in the morning presentation, but now we will have a much more detailed look on this. Let's start. LEDs produce no heat. This is for sure true if we talk about what LEDs emit. So the light that we get from the LEDs is completely free of heat, completely cool, yeah? Which is pretty nice for many applications. But this doesn't mean that the LED is not producing any heat. Some customers, they sometimes have a closer look at our products, like here the low caster, and they recognize there's a quite massive heatsink on the back. Or for example, these Fresnel units, the L series, they have a fan on the back. So why do we have these kind of heat management systems? It's absolutely necessary for the LED. And if you have the chance to have a closer look at the LED themselves, you will also see that, I mean, the very small, cheap, like mass production LEDs, they have only these pins, but they are not powerful, like 60 milliwatts. That's not interesting for what things we want to do with the LEDs. So LEDs that we use, for example, in these units and also in the LED panel, are types like this, high power LEDs. And all these LEDs that have a little bit more power than 60 milliwatt, they have a heat management already included. So there's always a kind of heat sink below the LED chip, and it's absolutely necessary to get rid of the heat that the LED produces. Because, I mean, all the other technologies, especially tungsten and HMI, they produce also heat, but they emit it. So you can say the advantage that the LED doesn't emit any heat is for any manufacturer like ARRI. For us, it's a disadvantage because now we as the manufacturer, we have to care for heat management. So all the LEDs that we use, they are connected to a bigger heatsink, or we have, like I told you, a fan-cooled system to get the LEDs cooled down. If we don't care for that, if the LEDs get too hot, I mean, they don't explode or something like this, but they will get dimmer, dimmer and dimmer, and they will lose their efficiency. And if you keep the unit running for half a year or 1 year, you will be surprised where all your bright LEDs are gone. So heat management is very, very necessary for LEDs. There's one more important thing. Forgot about that. It's always important to remember. And this is something that is not what I say or what ARRI says. This is from Philips. Maximum 50% of the electricity an LED gets is transferred to light. So on the other side, it means 50% of the energy is just heat. Yeah, so it's lost energy. And if we know that, for example, this unit consumes around about 170 watts, so we have 85 watts of heat, which we have to take care for. Heat management. Other important topic, if we talk about LEDs and heat, this slide, LEDs, they are also influenced by heat. So if an LED gets hot, it dims down. All LEDs do this, but they do it different. Blue or green or white LEDs, they are not affected so much by heat compared red LEDs, or in the most extreme way, yellow LEDs, they are extremely affected by heat. So if the LED gets warmer, and in every system the LED get warmer, as soon as I switch the fixture on, the LED gets warm, they dim down. This is especially important to care for if we have, like ARRI does, fixtures that use multiple LEDs. ARRI doesn't produce fixtures that only, for example, use only white LEDs. There's a certain reason why we do that. I will explain it later. Just for now, we always use more than just white LEDs. For example, these units use blue, green, white, and red LEDs. It's always a mixture. So if this is always a mixture, and we would not care for this behavior of the LEDs, this would mean we switch the unit on and are, let's say, in tungsten mode, tungsten light, and half an hour later, the red LEDs dimmed down because of the heat. So the unit is not producing tungsten anymore, it's producing daylight. So nobody wants that, of course. We want to have a stable color temperature, a stable color. So this is why we have to care for these behavior. And yeah, how we do that, of course, we measure the temperature. All the time temperature is measured, and microprocessor controlled, we adjust these degradation. So we always take care that we always have the same output from all the LEDs. They always give us the same light. And this means, of course, also that there must be enough, let's say, headroom for the LEDs. Yeah? If we start a unit and run at 100%, there's no chance to adjust. So we always start the units dimmed down, and then with the temperature, we have the chance to adjust this. So you have guaranteed that it doesn't matter if you are shooting in Greenland or in a desert somewhere, it doesn't matter. You always have the same color, always. And of course also the same brightness. Next point, which refers to the heat management, is LED lifetime. LEDs have a very, very long lifetime, long-lasting technology, but once again, this is also only true if you care for the heat management. There's a little bit more complicated chart. It's also from Philips. What do we see here? Here, lifetime. So at best, the LEDs here, they can achieve 60,000 hours, which are many years of lifetime. But it depends. Here on the x-axis, we have the so-called junction temperature. This is not the temperature that a fixture has, so don't worry, the fixture doesn't get like hot as 150 degrees. This is the temperature inside the LED. So if the LED gets too hot, then we lose the long lifetime. LEDs will dim down very soon. And if it's like an extreme temperature, they will really just stop to give any light at some point. Besides the temperature that we have to care for, it's also how we drive the LEDs. LEDs are driven by a stable current of 350 milliampere, for example, or 1 ampere also possible. But the more current we put into the LED, of course, the more light we get. So it's always like, I would like to have a little bit more light, so push it a little bit. But once again, if you put too much current inside the LED, you will lose lifetime. So it's always better to stay a little bit more conservative and to just care for that you have a long lifetime with the LED. It's no use to just like have the brightest LED light for Cynic, so everybody is like, whoa, what do you have? But half a year later, all these fixtures are dimmed down. Usually when we develop the fixtures, they are planned to have them in the studio for like 10 years or something like this. Yeah? And they should like have a stable light output over all these lifetime.